A very important first step in being able to name a compound or understand its properties is being able to tell whether a compound is molecular, is it a covalent molecule, or is it an ionic compound. An ion is an element that has a charge. So we have two different kinds of ions. Ion is a more general term. If the charge is positive, we call that ion a cation, and if the charge is negative, it's called an anion. Remember that the number of protons can't change without changing the identity of the element, so that doesn't happen. The charge happens by gaining or losing electrons. Some elements, when they do gain or lose electrons, do it in a very predictable way. So we'll take a look at the groups of the periodic tables and see which elements we can predict the ions for. Let's take a look at the periodic table to see which of these elements have a predictable charge. The elements that are in this first family here, the alkali metals and hydrogen, can have a +1 charge. So this whole family here, when they are charged, would have a +1 charge. It is definitely possible for hydrogen or sodium or any of these elements to not be charged. We learned about that with the isotopes, figuring out how many electrons something has. So some students get confused. I wanted to clear that up. We saw before that if you have no charge written here, then this isotope of sodium would have 11 electrons. It would not be charged. This isotope here with a +1 charge only has 10 electrons. So it is possible for sodium to be not charged, and it's possible for sodium to be charged. When sodium is charged, when it does form an ion, that ion is always +1. It's never +2, it's never -1. So that's what we're saying here. We're not saying that all these elements are always charged, but when they are charged, this is the charge that they always form, and that makes it predictable. So the second family over here, when these elements do take on a charge, that charge is +2. The noble gases do not usually form charged atoms, but the halogens, it is very common to form a -1 charge ion. Then this group over here, at least for the nonmetals we're talking about. So we're talking about these elements over here. These elements are not very stable, so we don't know as much about them. Probably they would form a -1 charge, but we'll just worry about these nonmetals. These nonmetals over here form a -2 ion when they do form ions, and these would form a -3 ion when they form ions. Carbon and silicon tend to not form ions. They tend to become molecules and participate in molecular compounds rather than ionic compounds. So we won't put a charge for them. And the other elements that form a predictable charge kind of go along this W here in the corner. Aluminum and gallium form +3 ions when they form ions. Zinc and cadmium form +2 ions when they form ions. And silver, when it forms an ion, it's always a +1. So this is the extent of the elements that form a predictable charge. We do have some other elements, the transition metals especially, that have a variable charge, and we'll talk about that a little bit later. So anything that we didn't just point out as being predictable would be a variable charge. So many of the transition metals can take on more than one type of charge. For instance, iron can sometimes take on a +2 charge or sometimes take on a +3 charge. So we consider iron variable. Another type of ion we can have is a polyatomic ion. And this is a group of non-metal elements, and the non-metal elements themselves are held together by covalent bonds, but overall the structure has a charge, usually a negative charge. There is one exception, ammonium has a positive charge, but the other ones all have a negative charge. And we are going to have to know the names of these polyatomic ions. We'll get back to that in just a moment. So when we see a chemical formula, we should try to recognize whether it's an ionic compound. And to be an ionic compound, it would have to be a cation, something with a plus charge, and something with a minus charge, because we need that attraction between the positive and negative. So things that are positive could be metal elements when they form cations. We looked at that in the periodic table. The elements that form cations are in the metal side. The one polyatomic ion that we have that is a cation is ammonium. So if we have an NH4 group, that is a cation. It has a +1 charge. And then the things that could have negative charges are either nonmetals or the polyatomic anions from that list. So if you see this combination, you know that you have an ionic compound. A covalent compound would not have ions making it up. It would be held together not by attraction between positive and negative charges, but by shared pairs of electrons, which are called covalent bonds. So if you see a formula that is all nonmetals, for instance PCl3, we know that this is not an ionic compound, because if it were an ionic compound, phosphorus would have a -3 charge, and chlorines would all have -1 charge. And so if we tried to combine these as ions, we would end up with a -6 charge altogether. And we can see that we don't have that. We have a 0 charge. So this is not what's going on here. These are being held together by covalent bonds. It's not ionic. So this is covalent. The one thing that you should be careful of that might look like it's all nonmetals is something that has an ammonium ion. So maybe ammonium chloride. This one is made of ions. We have the ammonium ion that is positive charge and the chloride ion that is -1 charge. And so together they can make an overall 0 charge ionic compound. But other than something with ammonium, if you see all nonmetals, you'll know that it's a covalent compound. So here we have some elements that can all form ions. And some of them are predictable, some of them are variable. Let's practice predicting what the charges would be, or writing variable if we know that it's a variable element. So sulfur, when it forms an ion, has a -2 charge. Sodium would be a +1 charge. Nitrogen would be a -3 charge. Titanium is in that area of the periodic table that is variable. Calcium would have a +2 charge. Iron is variable. Fluorine would have a -1 charge. Strontium would have a +2 charge. Phosphorus would have a -3 charge. Magnesium would have a +2 charge. Gold is variable. And silver would have a +1 charge. All right, so if we know what ions are being formed, we can try to put them together and make a compound that has an overall charge of 0. So when you write the chemical formula of a compound, they have an overall 0 charge. Even if it's an ionic compound, the overall charge is 0, and we don't write the formula with the charges showing. The charges are showing here because this is not a complete compound. This is just a lithium ion, and this is just a carbonate ion. But when we make lithium carbonate, we don't have the charges showing. So here, you'll notice this has a -2 and this has a +1. So to get it to be 0, we need another lithium. That's why the formula shows 2 lithiums and 1 carbonate. So for this one, magnesium is a 2+. We need another bromide ion, another bromine with a 1- to make magnesium bromide. And we write the formula with 2 bromine in it because it needs 2. Here we only need 1 of each, so we can just write the formula like this. Here titanium is +4, so we need another oxygen or another oxide anion. So we would write the formula like this. Here we have a little bit of a mismatch here. A 1-to-1 ratio will not work. So you can use least common multiples to figure this out if you like doing that, or we can just go back and forth. We need another magnesium, and that's still not good because now we have too many positive, not enough negative. So we need another nitrogen here. Now we have too much negative. So now we need another magnesium, and we have a match. We have +6 altogether, -6 altogether. So we can write a formula with no overall charge, and that formula has 3 magnesium and 2 nitrogen in it. So here the strontium is +2, so we need an additional nitrite ion. If we just try to write NO2 and write a 2 next to it, this looks weird because it looks like there's 22 oxygen and only 1 nitrogen. We're trying to say that we have 2 nitrite groups, so the way we have to write this is with some parentheses around the polyatomic ion to show that we want 2 of that ion, not 2 of the last thing written there. So let's do a little bit extra on this table and see if we can name these compounds as well as writing the formulas. And when we name an ionic compound, it's important to know whether the metal is a predictable or variable charged metal. So let's go through and note that. Lithium is one with a predictable charge, so is magnesium. Copper has a variable charge, it's in that transition metal area of the periodic table, and so is titanium. And then we have a couple more predictable ones. So for the predictable ones, we can just name the cation and name the anion. For some of these polyatomics, that might be easier said than done. But this is the lithium ion, and this is the carbonate ion. So this compound is lithium carbonate. Here we have a magnesium ion. And remember, when we have a single element that takes on a negative charge, we change that ending to IDE. So bromine becomes bromide. So this is called a bromide ion, and this is magnesium bromide. Okay, so let's skip the variable for now, and we'll name this one magnesium. Nitrogen, when it takes on a charge, is nitride. So this is magnesium nitride. This is strontium. This is the nitrite ion if you look on your polyatomic chart. And so this would be strontium nitrite. So be careful with spelling. Some of these have very close spelling and mean very different things. Okay, so this is one version of copper that can form. Copper is a variable ion though, so we want to specify this is not just the copper ion, this is the copper 2 ion. We specify what the charge is with the Roman numeral. Same thing with titanium. This is not just a titanium ion. Since titanium is variable, we have to specify that this is titanium 4. Then this we have sulfate from our polyatomic ion chart. Oxygen, when it takes on a charge, is oxide. So now we can name these. We have copper 2 sulfate and titanium 4 oxide. Okay, I've been referring to these polyatomic ions, so let's take a look. There's a chart on page 26 in your note packet of some polyatomic ions that we should know, meaning that we should know the formula, the charge, and the name of the ion in order to be able to make these chemical formulas or to name the chemical formulas. Okay, so the first 5 ions that you should learn if you're just starting out are these 5 over here, these 8 ions. First of all, they're very common, so even though 5 out of 25 doesn't seem like a lot, in reality you're going to see them a lot more, and so you will get more of the compounds named correctly. When I learned these, I learned the acids first. So for instance, I knew that phosphoric acid was H3PO4, and so I knew that the phosphate ion had a -3 charge because there are 3 hydrogens in there. So that is one way to learn them, to use the acids if you want to learn the acids first. Some of my students really like the mnemonic. I can't remember the mnemonic, so it doesn't work for me very well. But if you go on YouTube and search for Nick the Camel ion naming, something like that, the Nick has to do with nitrate, that it only has one vowel, so there's a -1 charge, something like that. So some of my students really like the mnemonic if you want to try looking for it. This mnemonic just helps you learn these 5 ions. But however you learn them, the first step would be to learn these 5 ions. And then once you learn these 5, I'll show you a pattern where you can get a few more, not the entire chart, but some more ions. And the first pattern is that going from 8 to ite, you keep the charge the same and you just write 1 fewer oxygen. So sulfate, if sulfate is SO4 with a -2, then sulfite is SO3 with a -2. If nitrite is NO3 with a -1, nitrite is NO2 with a -1. We don't have a carbonite, so I'm skipping that one. Phosphite would be PO3 with a -3, and chlorite would be ClO2 with a -1. Another pattern that we can see is that we can add a hydrogen ion to some of these ions. And when we add a hydrogen ion to sulfate, we can call it hydrogen sulfate, or we can call it bisulfate. So adding an H1 plus puts an H at the beginning, so we're adding the H. And since we're adding a plus, when we add a plus to this -2, we get a 1 minus. So -2 plus 1 makes -1. So the bisulfate ion is HSO4 with a -1 charge. We can do the same thing to sulfite, add a hydrogen there to make bisulfite, also called hydrogen sulfite, HSO3 with a -1 charge. For nitrate, we can't really do this because if we add an H plus, we get HNO3 with 0 charge, which is a compound, that's nitric acid, but it's no longer an ion. So it is not one of our polyatomic ions that we have to learn. So we are not going to do this to nitrate or nitrite, and we're not going to do it to chlorate or chlorite for the same reason. We can do it to carbonate. So we'll add an H, making HCO3, and then we add the +1, which changes the charge to -1. So this is the bicarbonate ion. I guess you could call it hydrogen carbonate, but nobody ever does. It's really commonly known as bicarbonate. For phosphate, we can add a hydrogen and make HPO4. This would have a charge of -2. When we add 1 to -3, we get -2. You could call this the biphosphate ion as well. This one is more commonly known as hydrogen phosphate, however. We can do this a second time, so I have this down here because I ran out of room up top, but we can add a second hydrogen to phosphate and have 2 hydrogens there, H2PO4, and that would bring the charge up to a -1. We don't have hydrogen phosphite as one of our ions to learn, so we won't worry about that. Another thing we can do with the chlorate and chlorite is to change the amount of oxygens. We can't really add a hydrogen with a +1 charge, but we can have something with even more oxygens than the chlorate ion. So if you have too much of something, like if you have too much energy, you could be called hyper. If your blood pressure is too high, you're hypertensive. If you have too much sugar in your blood, you're hyperglycemic. So hyper means higher or more of something. So having more oxygen for chlorate, instead of hyper, we just use the per here, and we call it perchlorate. And that is a ClO4 ion with a -1 charge. If you're too low in something, the prefix is hypo. So hypotension is low blood pressure, hypoglycemia, low blood sugar. So this means low. This time we do keep the entire prefix. We don't abbreviate it like we did for this one. And this one we have a lower amount of oxygen. So just 1 oxygen with the chlorine, and a -1 charge. So that is the hypochlorite, 1 lower than chlorite, and this is higher than 8, so it's perchlorate. So this isn't the entire chart of polyatomic ions that we need to learn, but it is more than half. We can try to have these patterns help us to learn them.